In today's video, let's talk about three levels of agents, which is text agents, large language model agents, and reasoning agents. And I will using concrete examples and explaining how they differ from each other. So the first level is text agents. A text agent is an AI that interacts with its environment by using text-based observation and text-based actions, but it doesn't necessarily rely on the advanced language models like large language models. So these agents receive input, which is observation in the form of the text, and process it, and then respond action in a text form. So they operate in a purely just linguistic space. The first example is Eliza. Eliza was an early text-based AI developed in the 1960s, so it simulates a conversation with a user by just using pattern matching techniques to respond to input. It doesn't understand the conversation, it just simply follows the pre-programmed rules. So environment is the human user interacting with Eliza via text, and the observation is the user's input, for example, which is I feel sad today, and the actions by the Eliza response, which is based on predefined patterns, for example, why do you feel sad today? It uses a very simple keyword-based pattern matching to give these responses, which making it an earlier example of a text agent. There is a more advanced example of a text agent, which is the LSTM-DQN, which is long short-term memory plus deep Q network, which is used in some reinforced learning contexts. Well, the agent interacts with a text-based environment, like text-based games. So the environment is a text-based game. Well, the players has to explore, collect items, or fight enemies by using commands. The observation is descriptive text that informs the agent of its surroundings. For example, you are in a dark cave and there is a sword on the ground, and the action is the agent take a text-based action, for example, take sword or go north to process in the game. So here, this agent uses a combination of natural language processing techniques to interpret the environment and then decide on the best action. And the second level is the large language model agent. So this is a more advanced form of text agent that specifically use large language models to interact with its environment. The large language models has its ability to understand and generate text, which is a much more complicated way compared with the older method. So the key is that the agent uses the large language models to interact, its process like observation, and generates actions by leveraging the large language model's ability to understand context and provide nuanced responses. Another example is SayCan, which is an example of the large language model agent that integrates a large language model with a robot to perform tasks. So it uses language to process the complex commands and decide how to act. The environment is in this physical world where the robot interacts with objects and people. So the observation is the spoken or written language comments from a user, like, can you get me a soda from the fridge? The action is this large language model understand the comments and translate it into actions so that the robot can perform, like navigating to the fridge, opening it, and retrieving the soda. So here, this large language model is used to understand the complexity of human language, which is including ambiguous or imprecise commands, so that it can break it down into steps. Then the robot can execute in the physical world. And a language planner is another example of the large language model agent that uses the large language model to make plans based on text input. For example, the environment is a virtual world or text-based system, for example, which is planning a trip or managing a task list. So the observation is a set of tasks or goals provided by the user. And for example, planning my trip to Paris or just a visit to Louisville or some good restaurants. The action in this agent generates a step-by-step itinerary using the large language model's ability to process such large amounts of information and plan coherently. So in these cases, this large language model agent relies on the large-scale training data and sophisticated language processing to act in response in text input, which making them much more flexible and intelligent compared with the simpler text agents. And the third level is reasoning agent. So a reasoning agent takes things further by not just only using the large language model to act, but also using it to reason and solve more complex problems. So these agents can go beyond surface-level language understanding and engage in multi-step reasoning, decision-making, and problem-solving by using the large language model. So the key differences here is that the reasoning agent don't just respond to the text input, but they can think through the problem before they acting. And another example is React, which is a reasoning agent framework, where the large language model-based agent reasons through its action by reflecting on past experiences and outcomes before it's making any decision. So the environment could be anything from a text-based game to a complex system where the decisions are made based on the incomplete or involving information. And the observation this agent could receive is the text-based input. For example, like you see a locked door and you have a key and a crowbar. The action is before acting, this agent reasons about this situation. For example, if I use the key, I might be able to open the door safely, right? But the crowbar could be break it, right? So it weighs different strategies and then choose the best course of action. So in this scenario, the agent is reasoning before it's making any decision, which is showing a high level of cognitive function than just simply react to the comments. And the last example is AutoGPT, which is an autonomous agent that can use the large language models to reason through multiple-step problem and break it down tasks into subtasks. So the environment is a wide range of possible environment, such as web-based research, business planning, or complex task automation. And the observation is a higher level goal from the user. For example, set up a website for my new business, and action could be the agent decomposes these tasks into smaller steps. For example, register a domain, choose a web builder, and then create a design. It uses reasoning to ensure that each step is logically follows the previous one and adapting if there's something unexpected happens. So reasoning agents like AutoGPT don't just execute instructions, but they can adapt problem solving and making decisions based on this situation by using the reasoning capabilities of the large language model.